Hello, I'm Clint Cole from Real Digital. Thanks to ECEDHA for organizing this conference where we can all come together to learn and work with each other to keep improving electrical and computer engineering education. I'd like to tell you a little bit about our company and share some thoughts about the state of engineering education. Now, lately we've got some recent data that indicates some issues are brewing with our educational system. ECE graduation rates are declining and enrollment is declining even more. Most declared ECE students will leave the major before graduating, and we're already producing too few graduates to meet anticipated demand. We're not even producing enough graduates to replace those who retire. This isn't the case in other disciplines. In fact, we're producing plenty of people to sell and to litigate the products our engineers are creating. Why are students leaving? On exit interviews, almost all students leaving the major cited similar reasons: poor teaching, difficult subject matter, boring classes, and flexible grading, and difficulty seeing the light at the end of the tunnel. Uninspired and demotivated students are a leading factor in our poor retention numbers, and that's something we can address. So at Real Digital, we decided to take the problem on head on. We made a t-shirt. Now, I brought enough of these shirts for everyone that wants one. Be sure to stop by our booth and grab one. We've already been working to improve students' perceptions and experiences. Many schools are engaging students earlier by offering more hands-on activities like project-based intro classes, updated design labs, and design-focused clubs. I want to focus on a proven step that many schools have adopted, but still that many have not: the common and extensive use of industry standard tools and technologies in entry-level classes. Studies show that students with their own design tools learn more, learn better, and learn faster when they can work at a time and place of their choosing, away from the bright lights and social pressures of the lab. They can and do spend more time, as much time as they need, using the tools of the trade to gain critical knowledge and skill. And completing significant designs using real frontline tools helps students feel more connected to the profession, and they get even more committed and involved. Well, that's where we come in. Together with AMD, our mission is to provide the best, most useful and relevant design kits that students can use to learn digital design. At Real Digital, we design and produce circuit boards with FPGAs and SoCs that contain the latest technologies, but always at prices that any student can afford. AMD produces the powerful, full-featured CAD software that lets students capture, simulate, implement, and verify any design, from simple first-touch circuits to complex digital systems. Now, this software is truly powerful and truly game-changing. And when every student uses this software every week, they can and do produce incredible hardware and software systems. In fact, within a few weeks, they are limited only by their imaginations, and they can prove their concepts and designs are solid using state-of-the-art technologies right on their desktops. It's really hard to overstate how amazing and how powerful this is. This technology is exactly what's needed to unleash the next generation of engineering brilliance. Students really must carry a design all the way through implementation. It's just too easy and too common to build false confidence after a successful simulation. I've worked as an engineer for many years, and in my experience, the most beneficial and practical learning happens after simulation and during implementation, when there's no room left for assumptions. So, what best practices should we focus on? Well, common thought: breadboards, 7400 logic, good for teaching basics. Not anymore. Now the basics are CAD, Verilog, and VHDL, and IP design, and hardware and software co-design. The school's design lab isn't the best learning environment. We know students put in more time when they can work at a time and place of their choosing. Using CAD and FPGAs does not take a lot of trained staff and long learning curves. We've learned that self-paced, freely posted tutorials are a proven and effective way to get students up the learning curve quickly and efficiently. CAD, FPGAs, and new technologies, new methods too much for freshmen trying to learn the basics? Nope. We've learned that these are exactly the tools they need to learn these skills, to learn this knowledge, and to be effective practitioners. Embedded cores can be added to a design just like any other block and configured using a wizard. I've got freshman students adding cores to their designs routinely. CAD is free, boards are cheap, less than a textbook, and there's no expensive systems for the department to maintain. And lastly, you don't really need experienced staff because the posted tutorials and reference materials pretty much let anybody with relevant knowledge successfully run a course. We know that students that own their own tools learn more, learn faster, and retain the information longer. We know they perform better on homework and tests and that they enjoy the experience more. The essential skills today absolutely include mastery of CAD tools and HDLs and FPGAs and the ability to create and to use custom IP blocks. Every student can own a state-of-the-art design station for less than the cost of a textbook. And we know that when students own their own tools, they use them far more than they could or would if they were confined to a lab. Bottom line, it's cheaper and easier and just plain better for everyone when students own their own tools. And in fact, students that don't own their own tools are at a disadvantage. The argument for every student owning their own tools is solid. And the current standard of practice is that each and every student has their own design kit. How do you do it? Well, we think it's simple. Come see us at Real Digital. We produce the best boards, the lowest cost, the most features, and the most support. When should you do it? Well, those free shirts you come and pick up from me, that's why the back of them says this. The time is now. All right, at Real Digital, we produce 2 different FPGA boards for digital logic design, and both of them were designed specifically for students. The Boolean board is the lowest cost FPGA board available, and it has far more features than any other board in its class. It has lots of I/O devices, an onboard audio circuit, analog to digital converter, a Bluetooth radio, UART, HDMI, everything needed to implement a wide variety of designs, and all driven from a large FPGA. The Boolean board is a complete standalone system that includes everything a student might need to design and implement a wide variety of circuits and systems. The Urbana board is based on the Boolean board, but it adds a large, fast DDR3 memory array, a USB host, and a digital microphone. So in addition to hosting any given logic design, the Urbana also makes an ideal host for soft-core processors like the Microblaze or the RISC-V. Now our Blackboard is based on AMD's Zinc device that includes an FPGA and an ARM processor. This one board can be used across the entire curricula. It can be used as a standalone FPGA board for digital logic classes, as a standalone ARM system for microprocessor classes, or as a combined hardware-software development tool for systems classes. I use the Blackboard every day for these 3 classes at Washington State University, and with great success. Students can learn a single CAD environment and then use it across the entire curricula and beyond. And then we have the RFSoC 4x2 board in a class by itself. With its large FPGA, multi-core high-performance ARM processing unit, and multiple high-speed ADCs and DACs, the RFSoC board brings amazing performance to a desktop system. With 4 5 gigasample per second ADCs and 2 10 gigasample DACs, RFSoC can host a wide range of high-performance applications like software-defined radio, test and measurement devices, quantum computing devices, many others. Thank you. Remember, every student needs their own personal tools. Everyone here needs their own shirt. Come see us. Thanks. Bye.